Now we are on to 2.5, and we're going to talk about the zeros, or the rational zeros of a function. Remember, all the rational zeros of any functions are when the function, what have you, crosses the x-axis. So those would be our rational zeros right there, and there, and there, and there. So now, so let's talk about if we were to be given a function, right? Let's say our function is, let's say x4 minus 3x5. Well, we want to find out how many zeros we could possibly have. All we have to do is look to the largest exponent, our largest exponent being here, right? There are the exponent being 5, so that tells me that there are a possible of 5 possible zeros, right? 5 possible zeros there. It doesn't necessarily mean it has 5, but there are 5 possible zeros in that function, right? But we also have to be careful about this, because sometimes we might assume things, and we should never really assume that we are going to have these zeros in terms of exponents. Remember, everything needs to be completely multiplied out for us to really know how many zeros there are. So let's say we had let's say we have x minus 2, right, squared, minus x plus 2 squared. And we want to find out how many zeros are in this possible function. Well, right now, this isn't really, it looks like it might be a quadratic, right? And we could possibly have 2 zeros. However, I won't really know 100% sure until I multiply everything out. So this first one, if I multiply that out, isn't that what? X squared minus 4x plus 4, and I'm going to subtract whatever is the second part, that's x squared, plus 4x plus 4. Okay, distribute that negative, so that's x squared minus 4x plus 4 minus x squared minus 4x minus 4. So now I'm just going to go through and take away all the things, right? These two, they cancel each other out, yeah? And then so if I combine the like terms, then our formula, actually, our function is actually negative 8x, because the 4's cancel each other out too. These cancel out, so my formula is only negative 8x. Well, that's only a 1. This function only gives me one possible zero there. So let's go on to our rational zero test, right? Rational zero test. And the rational zero test is just saying, hey, well, what kind of zeros can we have in here? So let's do just a simple example. So let's say that's x cubed minus 2x squared plus 3x plus 20. Well, to find here our rational zero, all we have to do is, since this first number, right, is just a 1, so all we have to do is look at our very last, our constant being a 20. So if it's a 20, then we just got to take all the factors of that 20. Factors of that 20 being 1 times 20, so 1, 20, 2 times 10, so 2, 10. There's 4 times 5, 4, and 5. Okay, so these are all possible rational, but they're just not 1, 20, 2, 10, and 4. They're positive or negative because our zeros can be either positive or negative. So our rational zeros are either positive or negative, and then from there to determine if any of these are actual zeros, we would use synthetic division and divide. So we can just pick one, synthetic divide, and if the remainder is 0, that will be our answer. But let's say we had a more complex formula, right? Function. So let's say we have a 6x to the 5th minus 11x fourth minus 3x cubed plus 12x squared plus 2x minus 3. Well, once again, we first look to our constant, right? We'll look to that first. Factors of 3 are 1 and 3, so we can have a positive, negative 1, positive, negative 3. However, we have a 6, right? So now our factors could be any factors of the 3 divided by the factors of the 6, right? So potential factors there, we could have, let's say, 1 divided by 6. So that's a potential factor, 1 divided by 6. 2 divided by, another factor of 3. 1 divided by 2, right? Plus or minus 1 divided by 2. 6 to 1 divided by 3, plus or minus 1 divided by 3. All these 6, 2, and 3 are factors of 6. We could also have 3 divided by any of the factors of 6. So 3 divided by 6 is 1/2. That's already covered. 3 divided by 3 is 1. That's already covered. 3/2? That's possible, right? Plus, minus 3/2. Because that's like 3 divided by 2 and factor of 6. And I believe we have it. That is all the potential zeros, or all potential zeros of that equation.